Okay, guys, so this is second problem. It's about the friction. The problem says block A support a pipe column at rest as shown on wedge B. Knowing that the coefficient of static friction at all surface of contact is 0.25 and that theta equals 45 degrees. So it asks us to determine the smallest force P required to raise block A and draw clearly all necessary free body diagram. Okay, so I think some of you guys are still confusing about the force P. Okay, so let me explain that. So the smallest is force P to required to move an object is always going to be bigger than the largest force P in order for this object to stay in equilibrium. Like I said, if this is the break point, okay, and then so this is the break point, and then this, so the break point right here is the point where this object is bound to transit from equilibrium to motion. And this point right here is the largest force P for this thing to stay in equilibrium. Okay, and then this point right here is the smallest force P for this thing to stay in, for this thing to be in motion. Okay, so I want you guys to know the difference between those two. Okay, so back to the problem. Okay, so first thing, it asks us to determine the smallest force P required to raise the block A. So first we need to draw the free body diagram. Okay, so think about it. If I have a force P right here pushing the object B, what would it cost for the object A to move? Well, if I push this thing like that, object A obviously gonna slide upward, right? Okay, so as you can see in this figure right here, this free body diagram right here, since A is going upward, which this is the motion, and this is the motion of B. Okay, so since A is going upward, we know that its force F1 right here is going to go downward, side down. Okay, and then this motion is going upward too, so we know that F2 is going downward as well. Okay, and then we know that normal force is always pointing to the object, as you can see in normal force 1 and 1 and normal force 2 and 2 right there. Okay, and then if you look at this one right here, so I basically just break it down N1 and F1 into their X and Y components, so that so that I don't have to zoom in to the image for you guys to see. Okay, and then after we analysis, so for this kind of problem, you always want to draw the free body diagram of the object. I mean, how do I explain this? So for this kind of problem, you always want to draw the free body diagram of, like for this case, you always draw the free body diagram of A, because that's what, how do I explain this? So that's how, like think about it. So I have this P right here pushing the block B, and then to cause the motion of block A. So that for this kind of problem, you always want to draw the free body diagram of the block that is caused by the motion, and then you draw the free diagram of the block that's causing this thing to be in motion. If that makes sense. If that doesn't make sense, just shoot me an email, let me know. Okay, so after I draw the free diagram of A, I can draw a free diagram of B. We know that N1 and F1 right here, they're just going to be the opposite of what it. They're just going to be in the opposite direction of what it is on block A. Okay, and we know that the motion is going to the left. That means that F3, which is the friction force 3, is going to be going to the right. And then N3, like I said, normal force going to the object. Okay. Okay. So right here, right now, we can start doing our analysis. Like I said, for those kind of problem, all you need just an equilibrium equation to solve this kind of problem. So first, let's consider block A. So let's consider the free body diagonal block A. So if we consider it in the x direction, so summation force in the x direction. In the x direction, we have this N2, okay, going to the right. And then we have N1x, which N1x will be N1 sine 45. And then we have this F1x, which we know that the force will be equal to mu n, right? So I just said F1 cosine of 45, I just said F1 is equal to mu n. And n will be N1. Okay, equal to 0. And then we can rearrange this equation in terms of N1 or N2, but it'd be easier for me to rearrange this equation in terms of N2 because I can just simply just remove this whole thing over here. So that N2 will be equal to N1 sine 45 plus mu N1 cosine 45. Cosine 45, yeah, cosine 45. And I know that the mu is equal to 0.25. Okay, and then you can further break it down. So N2 will be equal to N1 sine 45 plus 0.25 cosine 45. Okay, and then simplify it, you get N2 will be equal to 0.884 N1. Okay, so that's it for the summation of force in the x direction. Let's do it in the y direction. Okay, so summation of force in the y direction. So in the y direction, we have this 3 kilonewton force going downward. All right, and then we have this F2 that's going downward as well. And then we have the N1y going outward, and then we have the F1y going downward. So let's write it now. So I got -3 minus F2 plus N1 cosine of 45 minus F1 sine of 45 equals 0. Okay. And then we know that F2 that's going to be mu s N2. All right, and then F1 going to be mu s N1. So let's further break it down. -3 minus mu s N2 plus N1 cosine of 45 minus mu s N1 sine 45 equals 0. Okay, and then we know that N2 is equal to 0.884. And then we can, so basically means that we can substitute that in. And then if we substitute that in, this entire equation only has one unknown, which will be the N1, since we know that mu s is equal to 0.25. So let's do that. So -3 minus 0.25 into 0.884 N1 plus N1 cosine of 45 minus 0.25 N1 sine of 45 equals 0. Okay. So let's further break it down. -3 minus 0.221 N1 plus N1 cosine of 45 minus 0.176 N1 equals 0. All right, let's further break it down. 0.31 N1 for 3. Then we solve for N1, so the N1 is equal to 9.67 kilonewtons. Okay, guys, so this kind of process is very easily to get wrong because there's a lot of number to play with when we do the algebra. So I want you guys to be careful with that. Okay, so that's for block A. Right now we can move to block B. Okay, so we determine what N1 is from block A. So let's do it for block B. Same thing. So you just summation forcing the y direction and summation forcing the x direction. So summation forcing the y direction. In the y direction, I have this excuse me, N3 going upward. I have this F1y going upward. I have this N1y going downward. Okay, let's write that. So N3 going upward, F1y, which would be sine 45 going upward as well. Then have this N1. Did I do this right? Hold on. I made a small mistake right here as I draw all the free body diagram. So as you can see from this one right here, this is my N1, this is my N1x, this is my N1y. Okay, that's right. Yeah, that makes sense. So that I have my N1y, which would be cosine of 45, N1 cosine of 45 equals 0. Okay, further break it down, N3 plus F1, which will be mu s N1 sine 45 minus N1 cosine 45. Okay. And then we know what N1 is. So basically just plug it in and then so that we can solve for N3. Plus minus 0.25 N1 9.67 sine 45 minus 9.67 cosine of 45 equal to 0. Okay, basically solve for N3. So we get N3 is equal to 5.12 meters. Okay, and then for so that we can move on to summation of the force in the x direction. So in the x direction, as we can see, we have this force P is going to the left, so it's going to be negative. And then we have a F3 going to the right, which would be positive. And then we have F1x going to the right, and then our N1x going to the right. Okay, so so let's write it down. So I have negative P plus my F3 plus my F1 cosine of 45 plus my N1 sine of 45. Okay, so based the elementary equation solve for P, so P will be equal to F3, which will be mu S N3 plus F1 mu S N1 cosine of 45 plus N1 sine of 45. Then we already determined all those unknowns from the previous steps. So basically just plug them in. So that P will be equal to mu S will be 0.25, N3, which would be 5.12 plus 0.25, N1 9.67, cosine of 45. Hold on. Plus N1, which is 9.67 sine of 45. Okay, solve for P. We get P will be equal to 9.8 kilonewtons. Okay, so this is the smallest force P required to raise block A. Then we did draw all of the free body diagrams. Okay. All right, guys. Like I said, this is a very so the level of difficulty for this problem. You can expect those kind of problems to be on the final exam. Like I mean the level of difficulty. Okay. So I'll see you guys in problem number 3.